Sorry about the technical difficulties. We're starting up now, though. Okay, so let's look at the lab assignment here for week 9. So we've done pretty much all the stuff we need to be able to do this lab assignment, but we haven't kind of fused it all together. So what I want to do from last week, we want to build on the script from last week, except for now, instead of just creating the shapefile we created last week, we want to create a new shapefile too. So really, start with the code you created last week, and what we want to do is output a new shapefile that contains the difference between the smallest circumscribing circle and the area of the input polygon. So what's going to happen, pretty much like we just demonstrated, we want to create a point, buffer it, and then clip it with the so for each city you want to find the centroid, buffer it, flip it with the same polygon, and then you want to create another shapefile that contains the circles that are the same as the inputs. In this case, what I would suggest you do is when you go to create that new polygon shapefile that's going to have that information in it, use as a template the city's shapefile, okay, or the city's data set. We can demonstrate that. We'll demonstrate creating a shapefile, but then we'll have you guys do and actually we'll demonstrate using that circumscribing circle script, just because that might be a little bit of a new thing. But then you guys can buffer it out and find the difference, which we just demonstrated how to do. All right, so that's the first script. The second script is that you're going to write a Python program that does the following. It's going to take a point shapefile that contains two fields. One field is called animal and another field is called time. And look at that. Time is just a number in this case, but time could represent an actual time, but in our case, lowest to highest. And then we're going to take a point shapefile, and that represents animal movements, that point shapefile. What you're going to do is from that point shapefile, you're going to create a line shapefile, one line per animal representing the movements of that animal from the earliest time to the latest time. I'll give you a little hint here. When we've done our insert cursors before, not our insert cursors, our search cursors before, we never used the order by. Maybe we did. Did we talk about order by last week? Look at that parameter. So when you create it, order it by the time field, and then it'll already be the way that you want it. So basically all this involves is reading the point shapefile and writing out the information into a line shapefile. That's all it is. So you read the points one by one, and as soon as you get to the next animal, the new animal, you write out the old animal and start writing the new animal until you finish, and then you write out the final animal. All right. Okay. Your program should also create a polygon shapefile that represents the animal's home range. So the home range is defined as the polyline shapefile buffered by 0.1 kilometers. So you can do this. This is like going back to what we did 2 or 3 weeks ago. This is just using the buffer tool. You could, if you wanted to, do that as part of this, but I would suggest just write the line shapefile out, then buffer it at the end. So then finally, your program should also find the amount of each animal's home range that is within each feature of the other data set called parts. Okay? So basically what you're doing here is you're intersecting all the home ranges with the parks to come up with the overall area. So, I mean, the number of area of each animal's home range is already in a park. All right, so let's start here on the first one. Okay. Let me see if, because we already got through a lot of that last week. You could turn it in separately. If you, yeah, lab 8. Did I not make a lab 8 on there? Oh, sorry. I'll make a lab 8 and a lab 9. Actually, no, we'll just make it, we'll just turn in a lab 9 and it'll be one script that does it all. Okay, I'll just make a lab 9. Okay, archive. Because it builds on it. All right, 2001, 2018. Yeah, so this is the shapefile. I mean, this is the one that does most of everything. It just doesn't. This one doesn't create that that last one, which is the SC circle. Okay. All right. So this script does most of what we had to do last week. It just didn't create this one last line, I think. Is there anything else we left out? That's it. Okay. All right. So just to finish that off. Well, actually, we don't need to finish that off right now. We'll let you finish that off. Okay. What we do need to do is we need to create that second shapefile. We need to create that second shapefile that creates all those polygons. So basically what it's going to look like, if I go back over here, I'm just going to get a brand new layer. I don't need this anymore. Save changes now. Okay, so if I look at this Lab 7 data, oh wait, it's not Lab 7 data, it's week 8. It's this cities 10 shape, right? That's the right, yeah. Okay. So what we want to do is find that smallest circumscribing circle, the smallest circle that will go around this shape. And then save that into a new shapefile. So what we can do here is we could save this in the same location. Yep. We could save this in the same location, but we need to run that SEC on every one. So you need to save this sec.py into the same folder. We kind of talked about that a little bit last week, but if you save it in the same folder, you can call it. I'm just going to open it back up again to refresh here. We're going to feed it a bunch of points, and these points are going to be either a tuple or a list of points. It's probably easier to do a list of points. And then that make circle is going to return a value. Let's test it real quick. Yeah, here's a test function. Make circle from 0, 0, 5, 5. So if I run this right now, I'm giving it 2 points, 0, 0, and 5, 5. The smallest circle that'll go from 0, 0 to 5, 5 is actually centered right in between 0 and 5. So it's centered at 2.5, and the radius is going to be 2.5. So let's see if it works. So we run the module. Yes, it works. So 2.5, 2.5, that's the center. No, sorry, that's the radius. 0, 0, 2.5. Yeah, that's the center. 2.5, 2.5. Sorry. Yeah, I was wrong. It's. Let me draw this. Paint. So what this is saying, if this is our x and y, 0, 0 is one of the points, and 5, 5 is the other point. Sorry, the way I first described it, I was saying 0, 5. So 2.5, 2.5 is the center, just like I said. However, this distance here is not 2.5. It's the hypotenuse of a right triangle whose sides are 2.5, which is 3.535. It figured it out for us. So that's the way to interpret that. This is the centroid. This is the radius. So to use that same function, we need to build a big data set that has all of. We need to build a big polygon that has all of the, or big list that has all those points. So we need to do that somewhere in our other code. That's right here. Somewhere in this code, we need to take this shape, which we're not, right now we're not getting the shape, we're only getting the shape area. So we need to actually get the shape. So let's do that first. So I'm adding this shape at, and that's going to do what? What's this going to return into the row? They're not points, they're cities. What? The whole I mean not the whole centroid, the whole shape. The whole polygon, right? Let's look into help and make sure that we know what we're talking about here. Go back, writing geometries. Let's do reading geometries because it'll be better. So these are all the geometry tokens. So shape at is the entire geometry object. Shape xy returns just the xy coordinate. So we want the whole entire geometry object. Okay. Now we actually want to get just the polygon. Just the points. So there is inside geometry, there is a method already for getting just the points. See if we kind of went over it. See if it's on there. For getting just the points. I think it's actually called explode. No, EX. Maybe it's under here. There is a way. One of these. I was just reading over it the last time that we. Oh, I think it was. I think it was simplify. Is it simplify? The one that changes the geometry to the next simpler version of the geometry. You guys remember when we talked about that? Maybe it's under just plain old geometry. Boundary. Yes. So boundary takes, but actually this won't actually help us because it only gets the endpoints. So if we get the boundary, we'll get the polylines, and if we get the boundary of the boundary, we'll just get the start and the end point. So that won't work. There's got to be a way to get there isn't. It doesn't look like. Okay. So we'll just have to do it the way we talked about last time. I thought when we were going over this, there was a method that allowed us to get just the points out of a polygon. But remember we did it last week. We just have to do a loop and a loop. Okay? So once we have the shape, the geometry, remember that it's made up of pieces that are called parts, and each of those parts is an array. So it can have multiple parts inside of it. So we just every time through the loop, what we need to do is to create a data set or a thing called points. I'll just call it points, I'll just call it points. Make sure we're not using that already. And that's going to be a new empty list. And so what we're going to do is we're going to inspect the geometry object for all of its points. So we have to do something like this. For part in row, and it's 0, 1, 2, 3, 4, 5, 6. It's row item 6. Then that's going to be a part. And for PT, which stands for point in part, right now, I'm just going to make sure this is working, and I'm going to print the point. Just to make sure it's working. So I'm getting, for each part in the row, I'm getting a point. For each part in the row, I'm getting the whole part. I'm taking the part and iterating through each point in the part. And then I guess I could also be going points. How do I add items to a? Yep. So I'm going to add all my points, but I'm going to say pt.x, pt.y, because I just want them to be a tuple, not an actual point object. I don't know if that'll work. Let's see what happens. It'll tell me if that happened. It is getting cold in here. That means that sec.py is not in the same directory. Yeah, point object has no. So let's see what it printed. Okay. So go like this, sorry. 0, 1. Because I don't know if I know sec.py doesn't like these nans afterwards. So instead of feeding it those nans, we're going to append this tuple. We're going to put this tuple into it because it does like tuples. That's what it likes. So we're going to construct a list of tuples. All right. So now it should be running, and we should see numbers just flashing up here all of a sudden. There's one thing that we still need to do in order to take advantage of sec.py, and that is that we need to take this points thing that we made, and at the end of the loop, after the loop, but not outside of this loop, we need to feed it we need to run that function that's inside of sec. Did this just fail again, or point object does not support indexing? Maybe it's point capital X, because Python is case sensitive. Geometry.
What did you change in the SEC file?
What's that?
What did you change? Did you change
I didn't change anything in the SAC file. I actually think that this might be .x big. Just a second. Append. Okay. You need to actually explicitly state that that is a tuple. Like that. All right. I'm sorry? Like up here? I'm going to go ahead and save this as, I'm going to save this up into week 9 and say this is 9-1. Yep. Okay. So this is, okay, go ahead, sorry. Go.
Can you explain the points got append? What does the double quote, double parentheses do for us?
Okay, so.
What do we have to capitalize the X and Y? Confused about the end of that line.
Okay, so I'll answer the capitalization first. So this point is an object, this PT is an object. In Python, it's case sensitive. And so to get the X and the Y data, you need to put a capital X because that's the way our GIS created it. The point object, to get the X, it needs to be a capital X. It can't be a lowercase x because Python interprets that differently than an uppercase x. Okay? So that's a pretty simple explanation, but that's the explanation. Okay, the parentheses is, maybe you didn't notice, but when I ran this the first time, it actually said, the first time I ran it, it actually said something like, what did it say? It said something like, not the first time I ran it, it said something like, append takes one argument, 2 given. And so this, I needed to append a tuple onto it. And so this parenthesis is a tuple, makes X and Y a tuple rather than just being 2 items in an argument. So here, let me do this a different way. Does that make a little more sense? So all this is doing right here is that SEC module that I copied from somebody else. It wants the points to be tuples. It wants a tuple, a list of tuples. So I'm constructing that list of tuples right here. That's what I'm doing. So this.
So we're trying to create that so that we can later call that function?
Exactly. Yeah.
Okay.
So I just wrote that a little differently because this is a tuple. Now we can see it's a tuple. And this is being appended into this points list. All right. Now I just noticed that this failed because there's a part out there that actually doesn't contain anything. So to fix that, I'm going to have to write something like print PT. So somewhere around here, I'm going to have to say something like, yeah, maybe right here, I'll just say try And then I'm going to indent all this. And then say except, there's a catch or except in Python. So what this is doing, oops, this print should be outside that. What this is doing is rather than dealing with an empty part, it's basically a part that's been created by something inside of ArcGIS. Somebody created it, and it doesn't have any points associated with it. I don't know how it got created, but it did. And so what I'm doing is saying, try to do this, but if it doesn't work, just print the word empty part so that it doesn't freak out. It'll still work because if it's an empty part, it won't really matter at all to the analysis. But that way we don't, our code doesn't die. So let's see how many polygons we have with empty parts. Well, actually, I'm going to delete this line so that I just get those. I'm going to run this again. Now it'll only print it if it's an empty part. So there's a polygon that's just not formed correctly. Maybe like when somebody was editing, they deleted something. Now I can't require a schema line. I might have to start and restart or something else. Okay. If you get that error, we're just going to try to open up ArcGIS again. I may have messed it up permanently by, yeah. Okay. It seems as though I tried restarting it in the very middle of the processing, so it was writing out to the file. Sometimes you can solve that by, let's see where I am, C, temp. I should have been more patient. SPA, lab. Gate. Sometimes you can solve this by deleting these files right here. That's not working anyway. But these lock files. Sometimes the only way I can get around this without rebooting is to temp is to recreate the data. SPA lab. So the problem that I just made was that and it looks like it totally corrupted my data anyway. See, I just totally screwed up the data because it's not even there anymore. So what I'm going to do is delete that data set. It won't even let me do that. What's that? Okay, so last week I had created a data set. I'd created a copy. And so I'm just going to restore from that copy. So what you need to do is do a similar thing. So now I've got this copy. I'm going to close it. As I called it City 10 2. So now I'm going to run it. What's that? Well, I just, how I messed it up was that the program was running and I went to run and I hit run again. And so it messed up. It just tried to restart the program, and because it was already running, it was in the middle of doing stuff to the data, and it basically just destroyed it. I can't, right now I can't even delete it. Yeah, it'll be fine if you let it run. So I messed up. So it looks like there's 1, 2, 3, 4, well, about 10 with empty parts. But other than that, we're fine. And we still have those points that we want. Let's not print these points out because it takes forever. I was trying to correct that mistake when I messed it up. All right, so the last thing that we need to do here is run that SEC function. Let's, I'm going to open up sec.py again and copy this example. So notice that this is indented back to the same level as points. And instead of feeding it make circle this tuple of tuples, we're going to feed it our points. And we're just going to call this, center. Oh, sorry. I'll call it minimum bounding circle, MBC. MBC is what I'm going to call it. I'm going to print it. All right, so sorry that I messed up and reran that thing. Oh, something happened. Yeah, that's what I need to do, or this. Sorry. So, so what he was saying was, I could either say, up there I could say from SEC import make circle, or I could say from SEC import star, or I could just do SEC dot make circle, and that worked. So these right here are all the centers and the diameters of all the circles that go around the cities in Mississippi. So it appears as though there is one city that doesn't have any geometry associated with it. So we're getting an error right here. So let's just ignore that circle. So to do that, we need to put another try statement in. Try, and then say catch, or no, find, accept. And then I'm just going to write print bad city. And then I'm curious to know what city it is. So I'm also going to print the 0, 1, 2, 3 plus row 4. 0, 1, 2, 3. No, it's 3. That's what I said. But I wrote it. So I'm interested to know which cities don't cooperate well. There's something about their geometry that it doesn't work in that function. That make circle didn't work. So I'll run it again. And now it should work. It's going to print all of the the data sets. This is all the circles that we want. See if we see a bad city pop up here. Must be a really big city that it's running all that code to figure out the minimum bounding circle. So it's taking a little while right here, or it finished. Did it finish? No, it's not finished. What's that? None. Oh, go back over here. So, print NBC. So sometimes it's print NBC is none. That's the print.
I keep this block and stuff.
None means that the object's empty.
Well, yeah.
Are you guys getting errors down there, it sounds like?
Yeah.
Well, I was there on the computer at home.
Okay.
Still trying to use that file.
Yeah, I still have that file too, but since I didn't want to reboot my computer, I just copied a new version of the file in, and I'm just ignoring that file. I had to put a different name up here. That's the way I handled it. So it's still running. It's taking a long, long time. So what we might want to do for testing purposes is run simplified geometry on the data set. What's that? I didn't see. Did you finish?
I got Bradley.
What's that?
I got Bradley.
Oh, okay. So you did get a bad city.
I got more than. That's not done. That's still active.
Yeah, it could be that that it shouldn't be random that we all get different bad cities, but perhaps. Oh, I got a bad city, Laurel. Bad city, Sherman. Okolona. Because this is like taking a really long time, I think what I'm going to do is go back into ArcMap and let's cartographically simplify these data, and maybe just do like, well, let's keep all of Mississippi, but we'll simplify the cities a bit. I don't know why ArcMap. Oh, it is opening. Because this is literally taking forever. Not literally, I guess. Plus, it might help solve the problem. So I'm going to walk you through doing that. So we are in C. I'm in C temp, and I've got my data set in SPA lab. And then I've got this week 8. Now this is my current data set. All right. It's in the middle of working. I'll bet you I just screwed it up again. Nope, it's still running. Hopefully it'll keep running. Okay, let's take the copy. So go back and get the original data set, if you can. And then go under cartography tools, generalization, and simplify polygon. So what this will do is it will it'll remove extraneous bends. So anything that's bending less than a certain amount, it'll take out. So I'm going to input the copy data set. I'm going to try to run it on this data set because it's not going to be as complicated. I'm going to save this out to the same location, SPA Lab Week 8. I'll call this Cities 10 Simple. Let's do the, what's that?
What algorithm?
Let me see. Point remove keeps the critical points that depict the essential shape of a polygon and removes all other points. That's the default. Keeps the main shape of the polygon by removing extraneous bends in the outline. Point removes the default, so let's leave that. Let's change the maximum allowable offset, the minimum area to, let's change that to 5 square meters. All right. Just leave that. The default. Just leave that the default. Okay. All right, I'm going to say okay. Tolerance. Where's the tolerance value?
There should be a box underneath that.
Yeah.
And mine doesn't have.
Okay, we're working on mine. Okay. We're working with that.
Yeah. Well, that's lame. Okay. Well, this can be solved. We'll just go arc I dot simplify it's simplify polygon cartography. I mean, this is if it doesn't work for you. Choose the city copy, save it as C:/temp/ Maybe I did, but no, it looks like I clicked SPA Lab / week 8 / city 10 simple.shp, comma, point remove is the default, comma, tolerance. The tolerance is that the rest of everything is not required, so I'm not going to put it in, but tolerance is, I'm going to go 5. What's that? That's not required. Just accept the default, and then press enter. Did this ever finish? All right, that finished. I'm going to go look and see how it affected various places here real quick. It doesn't look like it, it changed it a whole lot. You can see if we zoom way in, you can see how it shaved that. See that? See the little purple that's underneath the green? It shaved it just a little bit. Now, what would be more striking visually is, see here you can tell that it's removed a lot of points off of the edge of that. Even though the shape is generally the same, it's removed a bunch of points. So, does this actually show the points it removed? No. Okay. So I'm gonna save this. I'm gonna take this point simple dot shape, copy, and paste it so that I don't have to redo it if it all dies. Point simple, copy. So I still have that point simple shape. And I'm going to go back here. Did this ever finish running? Ah, it did finish running. Okay, cool. But that literally took a long time. Literally a long time. And we had a bunch of bad, not a bunch, but a fair bit. Sounds like everybody had different ones anyway. But let's see if it changes or improves the amount of time that it takes to run that if I run this on the simple data set. I gotta close it out of ArcGIS. I don't need to save it. All right, it seems to be going a lot faster, and it did. See how fast it completed? And all we did was simplify the data set, and I don't see any bad cities so far. I only see some empty parts, which is fine. Yep. So it finished, it did that really quickly. I'm pretty impressed. In fact, what we can do is print row 3, comma NBC. So now it's going to print for each city. It's going to print the name of the city and the tuple that represents its centroid and diameter when it finishes that. Okay. So this is the centroid for Biloxi. This is the diameter for Biloxi, Gulfports. Right. So every single city has one. There's no bad cities now that we've simplified the cities. It'd be interesting to see, it'd still take a long time to run, but it'd be interesting to see if we just ran the simplification tool, kept the tolerance at like 0.0000001, if just doing that would have fixed the bad cities, but not changed the polygons at all. But I want it to run fast, so I used 5. I ran it with 5, so that means that as long as the point didn't create a 5-meter difference in the original polygon versus the new polygon, that it deleted it. So you could see, we could see on disk. Go to probably best from here. If we go to C, temp, SPA lab, we can look on disk and see the difference between the two sizes of the data set. So the shapefile for the simple data set is 356 kilobytes, and the shapefile for the original data set, which is the geometry, is 1,328 kilobytes. So that's, less than a quarter of the size of the data set. That's smaller. All right. Okay, so let's see. What we need to do now is we have a point and we have a distance. And so what we need to do is build a point geometry with that information, with this information. And that point geometry is going to be a circle that just barely circumscribes that polygon. And it's going to be the smallest one that could possibly circumscribe that polygon. Okay. So to do that, we could go to the last example from today, this one, and we did that right here. So something like that. Our new polygon, I'm just going to call it new polygon because we don't need to do new polygon 1. Our new polygon is going to be arcpy dot point geometry. The point geometry that we're going to feed it is actually this point that we create. So we need to feed it that point. How do we feed it that point? Well, it's going to be MBC, and it's going to be 0 and MBC 2, or 1, 0, or 1, I mean. I do believe we need to put that in a parenthesis so that it's a tuple. So we're feeding it that tuple. And that may still not work. We may need to make that a point, a new point. But I think this will work because it worked before here. When we, well, not here, but file, recent, it worked right here. Yep. So we fed it an XY. We fed it a tuple there and it worked just fine. But this is slightly different because we're trying to build a point geometry with it. And then we're going to buffer that. We're going to buffer that MBC. What goes in this box right here? So this is the X, this is the Y, this is the buffer, which represents the size. That's this number right here. So this is going to be the center. This is going to be the buffer distance, which is this number right here. That's why we say 2. So we're making a new polygon that is the minimum bounding. But we're not actually saving it anywhere, but we've made it. And I don't know if it's going to work, so I'm going to run it. And then if it works, what we're going to do next is we have to save it to disk. Yeah, it worked. Oh, we got bad city on every single one, so it actually didn't work. The reason is because this is some different syntax. So let's go see how to build a point geometry using the help. Okay. So we need to make it a new point or a new array. So let's see if there's an example in the code. Way down at the bottom. Yep. So we just need to actually create a new point. So here's the syntax for creating a new point. In fact, a new point geometry. So let's do it like this. This will be MBC 0 and MBC 1. And And then we'll just put in, instead of that, we'll put in a point. So this really wanted a, it didn't want a tuple, it wanted that point object. Now, did I use the word point anywhere else? I don't think so. Just want to make sure that I didn't use this variable name somewhere else. I don't see it. I used points, but not point. So this should work. So now let's run it. And if I don't get any bad cities, then I know I did it. Then I know that it's working. The disadvantage of using a try statement, as we've just done, is that we can't see exactly where the error is. Well, I knew since that's the only line we added, that was where the error is. So it worked now. So now we've created a new polygon that represents that circle. Okay. And so now we need to save that out into a new file. Right now we haven't created a new data set. So we need to do that. We need to create a brand new data set that is the same as this data set. So what we're going to do is create a new data set and use an insert cursor and put the information into the new data set. All right. See how much space we're getting on the disk. All right. Yeah. Okay. And let's also look back at the lab assignment to see what it is that we're trying to do. We're trying to find that contains a difference between the smallest circumscribing circle and the area of the input polygon. We're trying to find that distance. Okay. So, I mean that difference, that area. Okay. So far, let's do that first. So we created this new polygon, right? And it's a circle. And what we really want to do is find the difference between that circle and the area of the polygon itself. We do have that already. So we have shape area right there. It's row, bracket, bracket, 0, 1, 2, 3, 4. It's 4. So we want to get this area and divide it by the area of this polygon we just created. Which one's always going to be larger? The circle or the area of the city itself? Exactly. So if we always want a number between 0 and 1, which one needs to be the numerator and which one needs to be the denominator? The circle needs to be the denominator. And if we get a value close to 1, what that means is that the area is very close to being a true circle. If the area is not 0, if the area is very far away from 1, then it means that our shape is really weird. It's really different. So we could call this what was it called in the lab? So I actually put it on the last week's lab. It's called it's just called circle. So but we won't call it circle because that's. Let's just call it C stat. Okay, it's going to equal the row 4, which is the shape area here, divided by the area of this new polygon. Now, to get the area of that new polygon, we can use a method of a polygon. So under the help, there is a method to get the area. Dot area. I'm actually going to move this print statement down here so we can see that value. I'm going to print C stat. So now I'm going to print this statistic, this ratio of the polygon area to the minimum circle. And I'm going to run that. I'll move it back over to here, and we'll look at it when it finishes.
While that's running, can you walk through that block of code on the drive?
This one.
So we ran the main circle, and then the point line.
Yeah. So,
Why do we need points?
okay, that's a good question. So, to create a new point geometry, it requires that we first create a point. A point geometry is a geometry object, and it required a point be created. I got that from the help on, there's a couple pages back, but I did still have it up recently. Is this it? This was it, right here. So a point is not a geometry class by itself, but it's commonly used to construct geometry. The example below, a point is used to create a point geometry object. So this is the line of code that I'm using to aid me. So these two lines of code here that says point equals arcpy.point, it's creating a point, and then that point is used to create a point geometry, which is what needs to actually be fed into the function to buffer. Buffering it, and then the buffer, we're buffering it by the distance that the sec.makeCircle calculated. So at first, the reason I wrote this to accept a tuple at first. Remember I tried to use a tuple here? Didn't work. It didn't work to use a tuple. But it did work to use a point geometry. For some reason, when you create an array, you can feed it a tuple, a list of tuples. But when you create a point geometry, it needs to be a point. So it's just the way ESRI has it set up. So this creates a point. This creates
That's a geometry, and then we create the polygon. And then that C-stack, that's where we're not going to calculate the area difference between the actual and the bounded circle. Okay, I got it.
Yeah, this is the, yeah. So this part right here created the point geometry, and then we buffered it to create the polygon itself. And then we took the ratio of the area of the city to the area of this new polygon. And then I printed that out. So now we have it right here, so we can see differences. I don't know which one's the highest. I haven't seen any above 0.6 or so far. .65. This one looks like one of the Palahatchee is still one of the smallest. Look at that, 0.09. Pretty small. So if there was a city that's pretty close to a circle, in fact, what we should do is include this in our statistic here. So I'm going to add a new field. I'll just call this C-stat. And I'll put that on the end. It'd be ideal to put it over there with the other ones over here, but I can't because I'd mess up all this other logic with these numbers for, so I'm going to take this cursor.update row and I'm going to move it all the way down to the end. Put it right here. And then I'm going to say row 6, 7. 7 is equal to CSTAT. So now I'm going to put that CSTAT value out in the data set so that I can sort it and find out which city is the most like a circle and which city is the least like a circle. So once this runs, I just called it CSTAT, but you can call it whatever you want. In the list of fields, I had to put the same thing. These have to match. This name has to match with that name. But here I'm referencing it by its order, row 7. Now when I look at it in ArcGIS, it's going to appear right after C circle. It's not going to appear way over there. I still need to calculate this S circle value, by the way. I haven't done that. Yeah. I put it at the end so that it wouldn't mess up, because all the code references it by the order that it's in. See, temp. SPA lab. And then what do we call this? Week 8. So now this simple data set here, I got to remember to close it up before I try to run it again. But now I have that column that says CSTAT, and if I sort it, I'm pretty sure Pelahatchie is going to be, yep, it is. So that's the lowest one, but let's see the one that looks the most like a circle, or that's this one. Whoa, look, it's almost 0.9. It's really close to 1. So that must be, yep, it is. It is a city that, Woodland. It's a city that actually incorporated everything a certain distance from its like town center. In South Carolina, this happens all the time. Like there's a whole bunch of cities. I came here from South Carolina. There are circles that start out. In fact, there's a lot of cities that start out as a circle and then they have like little things that they incorporated afterwards. Lots of them started out as circles. I don't know. It'd be interesting to find out exactly why it is like that. But in Mississippi, it looks like that's the only one that did it. Or if anybody else did it, they've gone way out of their original. So that's the second most like a circle. How different are they? Yeah, that's probably not right. The code again? Now, I mean, I don't know, but that shouldn't be a problem. You're not actually changing the row 4 value. Area. Well, when we do the next step, you'll be able to actually, what we're going to do next is put the circle on a map. So you'll be able to kind of see what's wrong with that circle. You're getting in there. Yeah, you're still ran.
I don't know. It says always says right? This is why I did and this right over here. I mean, like I did all of it. You know.
That's the line it's done.
Yeah.
You see how that one says stat, stats. So it was trying to find that C stats, but it didn't try to find it until I got to this line of code.
Simple. I thought that might have been drawing like city and simple. That's what it's like.
You deleted simple completely? Yeah, it looks like you deleted it completely. That's why it's not running. It's just saying it doesn't exist. So you need to recreate it. Yeah, simplify, not smooth. Simplify color. Whichever one, that should be exactly the same. Save it somewhere. Yeah, you can call it whatever you want. It's and then simplify tolerance at 5 is the way. And then say okay. You don't need to do that. It's right there. Yeah, so now feed it that. You will have to remove it. Go up and then change this to that. Yeah. You might. Oh no, you're gonna have to remove it from here.
Well, you can stay open.
I hope so. Let's click off of it. Okay. That's all right. Okay, so yeah, you're let's change so a second, come back. So Ashley, you're missing this line.
I'll listen. It's because I asked you questions.
No. So you're right. Where? Go back to it. Yeah, you're missing both of these 2 lines, and that's why. You see the line I have highlighted? You're missing that line. And then you also have to add this at the end. This.
Oh, okay.
Yeah, because what you're trying to do is you're trying to add, you're trying to change row bracket 7. It doesn't exist yet. All right. I'm going to delete it from here. I'm actually going to close down ArcMap. Okay. How are you guys doing on the coast? You need me to help some? You could send me some.
I'm still trying to get caught up. Could you scroll the code down just a little bit?
Sure.
I got way behind.
Yep. Fine. I think what I'm going to do is, yeah. So we have a new polygon that we created. What I want to eventually do is write this into a new file. But I haven't even created that new file yet. So that's what I want to do. So to do that, what I want to do up here is to create a second shapefile using FC as a template. So that's what I want to do. I want to create a second shapefile using FC as a template. In fact, what you could do, I like that idea better. Just create a shapefile using FC as a template, and then you're going to create it. Then down here, yep. Then you're going to change. Yeah. Okay. So we're using FC as a template, but then we're going to. Let's actually change it like this. I'll just show you what I mean. So we've got FC, right? We're gonna change. We're gonna call it PFC, which is gonna stand for pre-FC. And we're going to make the old simple shapefile be the original data set. And now we're going to create a new data set. So we're going to call this FC simple underscore out or something. Okay. So what I've done there is I've taken my PFC and now I'm not even going to operate on that file anymore. I'm only going to operate on my FC file. So all this data is going to, it's going to be, I'm operating on the new shapefile. Okay? So I still have to add that new shapefile code. Let's just copy that from a existing data set. I think we did it in 3. Yeah. So here's my create feature class. So I can do something like this. Here's my create feature class. My output path is going to be the workspace that I'm working in. The output name is going to be FC, and the geometry type is going to be polygon. So now I've created FC, and so I'm operating on this FC data set rather than the original simple data set. Yeah, okay. The only problem with doing it this way is that I'm basically trying to make the problem simpler, but I don't think that, I think to make it simpler, I need to do something a little bit different. But look at how I'm using the shape area here before I even get any further. And so in order to utilize the shape area, I actually need to do something different. I need to make an entire copy of the original data set. So we're not even going to use the create feature class. We're just going to say, we're just going to go and copy the original data set. And this will make the problem simple, or more simple. Copy data set archive. This is the ArcGIS Pro by accident, but that's fine. So rather than doing this create feature class, which is what we practiced, we're going to make the problem simpler and just say the in data set is the PFC and the out data set is the FC. And then we're actually going to update, the shape field instead of trying to, instead of building a brand new, instead of using insert cursor, we're just going to use an update cursor. And we won't practice the insert cursor until the next problem. So all we did was copy this data set right there. We copied it, and now what we can do, which one is the shape? 0, 1, 2, 3, 4, 5, 6. So it's 6. What we can do is update row 6 with the new polygon. So now, when we first create this data set, it's going to be just a straight up copy of all the cities, including the city boundaries. But by the time we're done running it, it's just going to be that circle that is the minimum bounding circle for that city. So I'm really only changed, I changed these lines of code, and I changed this line of code. That's all I had to do. Instead of working with two open cursors at the same time, I just made the problem more simple. But you're still going to have to open up two cursors with the next problem. You're just going to read the point data set and write it to the polyline data set. So now this will work like that. And if we look at this data set, then we can see the difference between, I mean, we can actually see the circles, because it's going to put those circles in. So now if I go to C, temp, SPA, lab, week 8. All right, simple and simple out. The good news, well, I'll wait till, oh, I didn't mean simple point, I meant simple out. Put that below it. Okay. So see how you can visually see how these two shapes are related differently than these two shapes. Okay. And so on. Now that we've got the one data set that is much larger than the second data set. That one's pretty close. There's Hattiesburg. Notice how Hattiesburg's circle goes way out over into Petal. But that's the smallest circle that will fit around Hattiesburg. I don't know, I mean, I don't understand all the math, but it's in that SEC data set, and that's the smallest circle that will fit. Small circle that will fit around Purvis and so on. Yeah, I'll go back to the code. All right. I think what I'm going to do now is this. I was going to wait till Aubrey got back. This is the. This is like for all the weeks. This is probably the most intensive, the most complicated that it's going to get. So now what we're going to do is start talking about raster. And raster, on its, just as a principle, raster data is much easier to kind of put together. It's not involved, it's not created with a lot of points and points make up polygons. And so working with raster data is actually simpler in terms of its concept than working with vector data. So what I'm going to do is talk about how to finish this one, and we'll talk about how to start the next one, but we won't get nearly as far into it. So let's talk about how to finish off this one. You got an error? Okay, we'll talk about errors in a second. So first we'll talk about how to finish off this one, and then we'll answer some questions, and then I'll talk about how to structure the second question. Okay, so all you have to do here to finish off this one is instead of these polygons like this, so this is still just a circle. See how when I close this up, this is a circle? Okay. What we want is the circle actually cut out with, it's kind of like it's like punching the hole, except we don't want to punch a hole with the circle, we want to punch a hole with the city. Okay. So that's what we want. So what we need to do here is take this new polygon and punch it out just as we did in the other code. So once you get this code working, it should be easy because you can refer back to this one, which was example 7. You should be able to refer back to this one and do something similar to this, except for your new polygon and your new polygon 1 are going to be different data sets. If you do get an empty data set like we did the first time, it's because your new polygon 1 and your new polygon 2 just need to be reversed from here. All right, so that's how you finish off that. So I'm going to leave it up here for a second and answer questions. And I'm going to stop the video right now and actually start it up and make a part 3, just because I'm worried that we're going to get too small.